In this question, we are given with an integrated common gate amplifier with current mirror pair circuit. So in common gate amplifier, you have to apply your input to source terminal of the transistor and you have to take output from the drain terminal of the transistor. And for biasing of this PMOS transistor, we have used a current mirror pair circuit with biasing current of 20 microampere. In the first part of the question, we need to find out following parameters: VA, width of all transistors, biasing voltage, transconductance, and output resistance, gain, and input output resistance of the amplifier. So we will start with this VA voltage. So as you can see in the question, the overdrive voltage is given as 0.15 volt for all transistor. So we can find out VA and Vbias by using this overdrive voltage. So the formula for overdrive voltage is VGS minus VT. For the formula for overdrive voltage is VGS minus VT for both NMOS and PMOS transistors. So let's say if we want to find out this VA voltage, then we can see the gate voltage and the drain voltage is same for third transistor. So we can write VGS3 is equal to VDS3, and overdrive voltage of third transistor is given as VGS3 minus VT equal to 0.15. So we can write VDS3 instead of VGS3, and VT is given as 0.5 volt equal to 0.15, and VDS3 is equal to VA minus 0.5 equal to 0.5. So 0.15. So VA will be equal to 0.65 volt. Now next is V biasing, the bias voltage. So to find out bias voltage, we need to first consider the operating point conditions. So while we are calculating or while we are assuming the operating conditions, we need to assume that the AC input voltage source is short circuited. So if we short circuit input voltage source, we can write VGS1 of first transistor as Vbias minus VDD, and VDD is given to us as 3 volt. So overdrive voltage of PMOS transistor is also VGS1 minus VT, and which is given as 0.15 volt. VGS1 we have already calculated in terms of Vbias minus 3 minus VT is minus 0.5. So minus minus will be plus, equal to 0.15. So this will be Vbias minus 2.5 equal to 0.15. So Vbias will be equal to 2.65 volt. So this VA is 0.65 volt and Vbias is 2.65 volt. Now let's find out the width of all transistors. So first of all, we can easily calculate width of third transistor. We can see that VGS3 is equal to VDS3. So when transistor is on and VGS3 is VDS3, the third transistor will be biased in saturation region. So we can use saturation current equation, which can be written as ID3 is equal to half mu n COX W by L of third transistor VGS3 minus VT square. So this VGS3 minus VT is VOB. So instead of VGS3 minus VT, we can write VOB. So it will be VOB square. So ID3 is given as 20 microampere, half mu n COX is given as 80 into 10 to the power minus 6, W by L 3 that we need to calculate, and VOB is 0.15 square. So from this equation we can calculate W by L3 as 22.22 micrometer, and length of the transistor is 0.5 micrometer. So we can calculate width of third transistor as 22.22 into 0.5 micrometer. So it will be equal to 11.11 micrometers. So width of third transistor is equal to 11.11 micrometer. Now let's find out the width of second transistor. As you can see, this M3 and M2 transistors are forming a current mirror pair circuit. So if we are ignoring VDS of these transistors, then we can write the ratio of current of these transistors as width of, or you can say W by L of, or ratio of W by L of these transistors. And in question, W by L of both transistors is same, so LL length will also cancel out, so simply we can write it as W2 by W3. So ID2 is 200 microampere, ID2 is 20, ID2 is 200 microampere, ID3 is 20 microampere, so it will be equal to 10. W2 that we need to calculate, we need to multiply W3 with 10, and we can get W2 as 111.11 micrometers. Now similarly we can calculate width of first transistor. So let's write the saturation current equation of mu p, because first transistor is PMOS transistor, so instead of mu n COX we have to use mu p COX. Mu p COX W by L1 VGS1 minus VTP square. So ID1 is 200 microampere of 20 into 10 to the power minus 6 W by L of first transistor, and this VGS1 minus VTP is VOB square, and VOB for the first transistor is also 0.1. So W by L1 is 888.89. So this is the ratio, so this will be a unitless quantity, so width of first transistor will be 808.89 into 0.5 micrometer. So width of first transistor will be 444.44 micrometer. So this is the answer for width of first transistor. Now in next part, or in next, we have to calculate GM1, GO1 and RO1. So GM1 of the first transistor is given by the formula 2ID1 by VOB, and we have ID1 as 200 microampere, VOB as 0.15 volt, so we can write GM1 as 266.67 microampere per volt. So GO1 we can calculate as lambda P, because this is the output admittance of first transistor, so we can write it as lambda P ID1. So lambda P is given as, so instead of minus value we have to use mod value, because this admittance or resistance cannot be a negative value. So ID1 is 200 microampere, so this value will be 10 microampere per volt, and simply we can also calculate resistance of first transistor, which can be given as 1 upon GO1, and it will be 100 kilo ohm. Similarly we can find out GO2, and GO2 will be equal to lambda n ID2, and lambda n is given as 0.1 multiplied by 200 microampere, which will be equal to 200 microampere per volt, and RO2 we can calculate by inverting GO2. and RO2 will be equal to 50 kilo ohm. So now next we need to find out Vout by Vin. So to find out Vout by Vin, we need to perform AC analysis, or simply we can say we have to find out Vout by Vin. To find out Vout by Vin, we have to uh, draw the small signal equivalent circuit of the given amplifier. So first of all, what we can do is this current mirror pair circuit is replaced by resistance of this complete current mirror pair circuit, and which will be equal to output resistance of second transistor only. So we can replace this particular part by RO2 of second transistor. So now the equivalent circuit will be like, so to draw the small signal model, what we need to do is we need to short circuit our DC voltages. So this Vbias is DC voltage source, so we can short circuit it to ground. VDD is also a DC voltage source, we have to short circuit it to ground. So our equivalent circuit will be having only this AC input voltage source. So if we draw the small signal model, we can draw it like this. So we have one resistance RO2 between drain of first transistor and ground. So this is the drain of first transistor, this one is gate, this one is source. And we have one more resistance RO1, which is the output resistance of M1 transistor, first transistor RO1. As you can see, this RO1 resistance is connected in between drain and source of the transistor. So we have to connect one resistance RO1 here between drain and source of the resistance, and we are taking output from at this node. So to find out VO in terms of GM1 VGS1, what we can do is we can apply KCL here. So let's assume the current across RO2 is I2, current across RO1 is I1, and current in this branch is GM1 VGS1. So when we apply KCL at this node, all are outgoing current, so sum of all these currents will be equal to 0. So we can write this equation as I1 is VO minus Vin divided by RO1, and I2 is VO divided by RO2 equal to 0. So this is our first equation, and from input side we can see this is our input side. So we can write VGS1 as VG1 minus VS1. VG1 is 0 and VS1 is Vin. So I can write VGS1 as minus Vin. So we can write this complete equation as VO upon RO1 plus VO upon RO2 minus Vin divided by RO1 minus GM1 Vin. So we can write this equation as 1 upon RO1 plus 1 upon RO2 is equal to Vin 1 upon RO1 plus GM1. So we can further write this equation as VO RO1 plus RO2 divided by RO1 RO2 V in 1 plus GM1 RO1 divided by RO1. So in denominator RO1 will cancel out. So we can write final gain as VO by V in as 1 plus GM1 RO1 multiplied by RO2 divided by RO1 plus RO2. So this is the formula for V out by V in. Now we have to put the values of GM1, RO1 and RO2. So V out by V in will be equal to 1 plus GM1 we have already calculated. RO1 is 100 kilo ohm. RO2 is 50 kilo ohm. R1 plus RO2, which means 100 plus 50 kilo ohm, 150 kilo ohm. So we can find V out by V in as 9.22 V by V. So this is the answer for voltage gain of given amplifier, which is VO by V in. Next we need to find out output resistance of given amplifier, which is Rout. So to find out this particular parameter, what we need to do is we need to short circuit input voltage source, and we have to connect a voltage source at the output, and we have to assume some current is flowing from that voltage source into the circuit. So our equivalent circuit will be now, so Vbias will be again short circuit. So this will be the circuit that will be using for finding out Rout. So Rout is V out by I out. So now let's draw the small signal equivalent model. This will be drawn, or this will be drawn in the same way as we were doing in finding out voltage gain. So as we can see, the gate terminal of the circuit and source terminal of the circuit both are connecting to ground. So VGS1 is 0. So when VGS1 is 0, the current source value is 0. If current source value is 0, then we can assume it as open circuit, and this RO1 and RO2 are in parallel. So we can say that the current which is coming from output voltage source, which is I out, is flowing through parallel combination of RO1 and RO2. So simply we can write V out as RO1 parallel RO2 multiplied by I out. So V out by I out will be equal to RO1 parallel RO2. and RO1 is 100 kilo ohm and RO2 is 50 kilo ohm. So parallel combination will be equal to around 33.33 kilo ohm. So this is the answer for R out, R in. So as we were finding out output resistance, same thing we have to do in finding out input resistance. Now what we have to do is we have to assume input current IN is coming from V in voltage source or input voltage source and flowing into the circuit. Now we have to draw the small signal model of this particular circuit and we have to find out V in by IN, which can be given as R in. Now assume that the voltage at this terminal is, let's say, Vx. So this IN current is entering into this node, and let's say current across RO1 is I1. So GM1 VGS1 is coming from this branch and I1 is coming from this branch. So when we apply KCL at this node, this IN will be incoming current, GM1 VGS1 will be incoming current, and I1 will also be a incoming current. So we can write or we can apply KCL at this point, and it can be written as IN plus GM1 VGS1 plus I1 equal to 0. From input side, what we can see is VGS1 is VG1 minus VS1, VG1 is 0 and VS1 is V. So we can write VGS1 as minus V. So now we can write I minus GM1 V, and I1 we can write it as Vx minus V divided by RO1 equal to 0. So let's say this is our first equation. So now let's say current across RO2 is flowing into this direction. So what we can see is this I2 will be equal to I in current. Why? If we apply KCL at this node, then you can see this I2 is incoming current and GM1 VGS1 and I1 are outgoing current. So let's apply KCL at this point. So what we can do is we can write it as I2 is equal to GM1 VGS1 plus I1. So now we can compare these two equations. So instead of GM1 VGS1 plus I1, we can put I2 here. So this equation will be I1 I in plus I2 equal to 0. So I2 will be equal to minus I in. So if we assume I2 in this direction, we can write Vx as minus RO2 into I2, and I2 is equal to minus I in. So we can write this equation as RO2 into I in. So the Vx from this equation can be put into this equation, and our final equation will be like I in minus GM1 V in RO2 into I in minus B in divided by RO1 equal to 0. So now we can modify this equation as so we can combine I in terms as RO1 plus RO2, and here it will be equal to V in 1 plus GM1 RO1. So V in by I in will be equal to RO1 plus RO2 divided by 1 plus GM1 RO1. So this is the formula for input resistance of the given amplifier. Now we can put the values of RO1, RO2 and GM1, and we can simply find out RO1. So simply we can find out Rin. So Rin will be equal to RO1 is 100 kilo ohm and RO2 is 50 kilo ohm. So RO1 plus RO2 is 150 kilo ohm. GM1 is 266.67 10 to the power minus 6, and it will be equal to 100 into 10 to the power 3. So Rin will be equal to 5.625 into 10 to the power 3 ohm. So this is the not kilo ohm, ohm. So it will be 5.625 kilo ohm. So this is the answer for input resistance.